Alright, so this is the second day of us graphing or talking about periodic functions and what they look like. Now you've seen the period, the midline, the amplitude, right? So you've seen all of these things up here. This is where we did all this yesterday. Today, we're going to take a look at one specific periodic function. This is actually the sine function. So you obviously know sine. We talked about it on the unit circle. We talked about it in trigonometry, triangles. This is what the sine function looks like if you were to put values in for x. So if you were to graph the sine function, this right here, y equals sine of x. If you were to graph that, this is what it would look like. All right. Number one thing, we're going to number one thing would be put your calculator in radians, all right? Just for this. Sometimes your calculator is good in degrees, sometimes your calculator is good in radians. Today we are talking about radians. Same thing with tomorrow, so just leave your calculator in radians. What we want to do is fill out this table, and then we're going to plot the points, and you'll see what it's like. All right. Today is the sine function. Tomorrow is the cosine function. I'm not going to make two videos doing the same thing. So today I'm going to walk you through how to do the sine function. We'll talk a little bit about the period, amplitude, midline of this. I'm going to have you guys predict some of these transformations. So obviously these can go through transformations. Predict what happens with A, predict what happens with B, predict what happens with H, predict what happens with K. All right, now we're going to get more in this at the end of the week, but I want you guys to predict here, and then tomorrow it's the same exact thing but the cosine function. So then go through the cosine function, predict what you think the cosine function will look like when you do the transformations, and then obviously we'll talk about the transformations on Friday. But let's go back to the sine function here. What I want to do is fill out this table. I don't know why this got cut off, but go ahead and put 2 pi right here. Okay, we want 2 pi. We want to plug these into our calculator, and then we will graph them. So I'm going to start with 0. Sine of 0. All right, here's how I'm going to do it. I'm going to pull up my calculator, TI-84. Go to mode. Make sure you are in radians. So here, radians is highlighted, so I'm good. I click enter, it's good. Okay, if you're in degrees, switch it over to radians. It's going to give you a different answer in degrees, so you got to switch it over to radians. Click that. All right, so I'm going to go sine of 0. Click enter. What do I get? I get 0. All right, so sine of 0 is 0. Good starting point there. All right, so let me 0, 0. Okay, sine of pi over 6, which is next. All right, sine of your pi button is right here by the H, so you probably maybe be able to see it, but right there. So sine of pi divided by 6. Hit enter. 0.5. All right, so I'll go back in the table. I will type in 0.5. Right, decimals are okay. If you see our coordinate grid here, the x-axis is actually our radians, and the y-axis is decimals or numbers, so we're good to just keep it 0.5. All right, and then we're just going to do this with all of them. So pi over 4, sine of pi over 4. Hit enter. What do we get? 0.71. It's okay to round here. 0.71. 0.71. Okay, and then we're gonna keep going and movie magic. 3, 2, 1, and voila, we have all of our points. What we're gonna do now is we're gonna graph these. All right, so we have all of our points here. Now we're gonna graph them. Shouldn't be too bad. 0. 0, so right there, pi over 6, 0.5, right there, and these are by 0.5 increments on the y-axis. 0.71, we can estimate that, so probably like right there, 0.81 right there, I got ahead of myself. Hang on. Got ahead of myself. Let's see. Pi over 6.5. Pi over 4, which is not on here. Sorry. Pi over 3 would be 0.82. Pi over 2 is 1. 2 pi over 3. 2 pi over 3 is 0.82, so that's going to be right there. 5 pi over 6 is 0.5. Pi is 0. 7 pi over 6 is negative 0.5. 4 pi over 3 would be negative 4. 3 pi over 2 is negative 1. If you really hate me talking and doing this, just pause it and, fill in the rest of the points on your own. Negative 0.82 right there. 11 pi over 6 is negative 0.5. 2 pi is 0. Alright, so you can kind of see what we have here. It is a periodic function. That looks something like this. If I was to trace all these points, hit and miss, it's okay. Okay, and it would start going like that. So what you have is a periodic function. Obviously, this is not going to go down like that. Okay, that's not going to happen. What you are going to see, though, is this going to go down to... it's going to go down to like here. Back up to like there. That's obviously a rough sketch. It's going to look something like that. The points that we see on there, I don't want to make you guys graph too many points. You already start to see the periodic function. If we look at the questions down below, what is the period of the function above? Remember, it's either peak to peak or valley to valley, but you could start in the middle. So if I started in the middle here, okay, I'm going to go up, down, I'm still going, and then until I get to the back halfway up, would be 2 pi. Okay, so what's the period of this function? 2 pi. It's from 0 to 2 pi. Okay, that would be the period. What is the amplitude? So remember how we find the amplitude? We go absolute value of max minus min, and then we divide that by 2. So if I do that, let me actually use a different color here. So we go absolute value of max minus min, and then we divide that by 2. Okay, so what's my maximum? Well, 1 minus what's my minimum? Negative 1. And then divide it by 2. 1 minus negative 1 would be negative 2. So we have the absolute value of, 1 minus negative 1 is 2. Divided by 2, which is 1. I know that's kind of backwards math there, but the amplitude in this case is 1. And that's by taking the max, or 1, minus the min, which is negative 1, and then dividing it by 2. So my amplitude is 1. The midline of this graph, remember, we have a pretty quick way of doing it. So if I want to find the midline, all I do is I look at the max and look at the min, and I find a place in the middle. My max is 1, my min is negative 1. What's in the middle? 0. Okay, so my midline here would be at y equals 0, because that's in the middle of the maximum and the minimum. Alright? In other words, it's 1 unit above the min, so that's 1, and 1 unit below the max. That would be where my midline is. Alright, so your job here for the rest of this is to... Oh, sorry, we have one more thing to talk about. In the previous lesson, we talked about if it is an even or odd function. So an even function, remember, an even function is symmetrical about the y-axis, while an odd function is not. So if I was to fold this on the y-axis, this axis right here, if I was to fold it, would it be symmetrical? The answer is actually no. Here is my, so here's what I had graphed, right? If I was to fold it over, it would look like that. Okay, so this part right here would actually fold back up here, which is not the direction that my graph goes. So because of that, what you have is an odd function. So this is an odd function because it is not symmetrical. Okay, it's odd because it is not symmetrical. About the y-axis is what we should say. Alright. Okay, you guys make some predictions here. What do you think happens if I multiply a on the outside, multiply b on the inside, add h, or subtract h on the inside, add k on the outside? You should, there are no wrong answers here. Make predictions of what you think might happen. Keep in mind what we've talked about transformations and how they work, and I promise you, maybe you have a head start on what we were talking about on Friday. So make some predictions here. Hopefully graphing these helped. You could also just do this if you really wanted to. You could go y equals sine x, make graph. And what do you know? It's exactly what we just did, but a little bit more, a little bit further. Feel free to use either option. Just be careful with your table because your table is not in radians. So be careful about that. Right? Alright, like I said, I'm not going to make a video for tomorrow's cosine because it's essentially this, just with cosine. So go ahead and do this for tomorrow. Find the period, the amplitude, the midline, even or odd function, and then make some predictions. Alright? Let me know if you guys have questions.